Calc PC, I thought I would just do the first two problems of the 2.6 homework so you can kind of get an idea of what the product rule is like. And I guess I'll do maybe a couple of other ones for quotient rule, or maybe just one of each. I don't know. Anyway, this is 2.6. I'm going to go ahead and look at problem number 1. I'm going to look at this as like an f of x times a g of x. And so if I have an f of x times g of x situation, my derivative is f of x times g prime of x plus g of x times f prime of x. So that's what I'm going to do here. I'm going to take my first function and multiply it by the derivative of the second. Plus, I'm going to take my second function and multiply it by the derivative of the first. And now I want to simplify. So 2x times x squared is 2x cubed minus 6x squared. And then this one I'll have to do x squared times 2x is 2x cubed. X squared times negative 3 is negative 3x squared. 1 times 2x is 2x, and 1 times negative 3 is negative 3. I've got my x cubes here that I'm going to combine. And I've got my negative 6x squared and negative 3x squared that I'm going to combine. And then I've got my plus 2x minus 3. And that will be my derivative. Now I just want to show you that if you decided that you wanted to multiply that out first and then take the derivative, we would get x to the fourth minus 3x cubed. So that would be this times this. I did this times this. Plus x squared, that would be this times this, and then minus 3x. So if I took the derivative of that, what would I get? 4x cubed minus 9x squared plus 2x minus 3. So either way, you're going to get that same derivative. And you just need to practice the product rule, though, because sometimes you can't multiply it out. They're giving you easy ones that you could check like that, but sometimes you can't do that. I thought that this one was tricky, number 2, so I'm going to go ahead and do that one also. So, like we said, our product rule is the first times the derivative of the second plus the second times the derivative of the first. Well, the derivative, I'm going to go over here. If I was taking the derivative of the square root of t, I would make it the derivative of t to the 1/2. I would bring the 1/2 down times t to the 1/2 minus 2/2. So 1/2 t to the negative 1/2, 1 over 2 times the square root of t. Okay, because derivative of 3 is 0. So now we're going to distribute. So negative 3, I've got my t to the 1/2 times my t to the second, which I'm going to make 4/2. And then we've got this one minus 9t squared. And now we distribute here plus, and then 4 over 2 would give me 2 over the square root of t minus, and then this is going to give me t to the third over 2t to the 1/2. And I'm going to make my t to the third t to the 6/2, because that's still t to the third. And so now we're going to simplify. -3 t to the 5/2 minus 9t squared plus 2 over the square root of t minus, and then if I bring this t to the 1/2 up, it's going to become t to the -1/2 up here, because you can't leave these t's, one in the top and one in the bottom. You got to combine them. And if I brought the 6/2 one down, it'd give me a negative exponent. So I don't want to do that. I want to bring the t to the 1/2 up, because when I add 6/2 minus 1/2, I'm going to get 5/2. So this is going to give me t to the 5/2 over 2. Now, I do notice that I've got a -3 t to the 5/2 and I've got a -1/2 t to the 5/2. Those are like terms. So I would have to combine those. And so this would be considered -6/2 and a -1/2. So that's going to give me a -7/2 times t to the 5/2 minus 9t squared plus 2 over the square root of t. And that would be your answer. Now, to check that, if we wanted to do like we did on the first one, if we wanted to go ahead and multiply this out, I would have 4 times the square root of t minus, and then that would be t to the 1/2 times t to the 6/2. So that would be t to the 7/2 plus 12 minus 3t cubed. And the only thing I didn't do is I should have written this as 4t to the 1/2. Because if I would have done that, I wouldn't have had to rewrite this again. So I could have erased it and done that, but now we can find our s prime. Bring the 1/2 down times the 4, I get 2t to the -1/2 minus 7/2 t to the 5/2, because I subtracted 2/2. That would be 0. Derivative would be 0 of 12 minus 9t squared. So 2 over the square root of t minus 7/2 t to the 5/2 minus 9t squared would be my derivative if I would have multiplied them out first. Do my derivatives match? Yes, they do. Okay, so that's your product rule.